Hi, good afternoon. These notes are on mean absolute deviation. I also call that MAD. So mean absolute deviation is the average distance between the data value and the mean, which helps describe the variability of the set of data. So a few pointers. If the data set has a small mean absolute deviation, then that means that the data values are relatively close to the mean and they're more consistent. If the mean absolute deviation is large, then that means that the values are more spread out and far from the mean. So there's more variability, it's less consistent. A few steps you're going to have to take to find the MAD. You have to first find the mean of the data, subtract the mean from each piece of data, find the absolute value of each difference, and then find the mean of the new difference. So down here we've got an example. Here are our numbers 3, 5, 10, 6, and 1, and we want to find the mean absolute deviation. So the first thing we need to do is find the MAD, or find the mean. So when you find the mean, you add all this together and divide by 5, and you actually get a mean of 5. Then what we're going to do is we're going to subtract the mean from each data value. So 3 minus 5 gives me a value of -2, but the absolute value of -2 is 2. And then we're going to do 5 minus 5, and 5 minus 5 is 0. And then 10 minus 5 gives me 5. And then 6 minus 5 gives me 1. And then 1 minus 5 gives me -4, but the absolute value of -4 is 4. So now we have all of our absolute value differences, and then what we want to do is we want to find the average of those. So 2 plus 5 plus 1 plus 4, and then divided by 5 gives me a MAD of 2.4. Now we want to compare some differences between 3 academic students. So the following are the math scores for Lee, Bessie, and Jamal. The first thing I want you to do is I want you to find their mean. So add 65 plus 82 plus 93 plus 100 and then divide by 4. So Lee's mean is 85. And then Bessie is 82, 86, 89, and 83. So add those and then divide by 4 and you get an average of 85 again. Jamal is 80, 99, 73, and 88. And then that average gives you an 85. And so they actually all have the exact same average of 85. So really we don't know who the better academic student is yet. Now we're going to find their medians, so make sure you put them in order from least to greatest. The median I found for Lee was 87.5. Then when I put Bessie's in order, the median I found for her was 84.5. And then the median I found for Jamal when I put him in order was 84. So now we're starting to see a little bit of a difference between the students. Then the last thing I want to do is I want to find their MAD. So I'm going to write all their data right here in the box. So 65, 82, 93, and 100. So in order to find the data minus the mean, we're going to take the mean of Lee, which is 85. So 65 minus 85 gives me a difference of -20, and the absolute value of -20 is 20. And then 82 minus 85 gives me a difference of 3. And then 93 minus 85 gives me a difference of 8. And then 100 minus 85 gives me a difference of 15. Then I'm going to find the average of these numbers, so 20 plus 3 plus 8 plus 15. And then when I divide that by 4, I get 11.5. So Lee's MAD, her mean absolute deviation, is 11.5 points. Now I'm going to do Bessie. So 82, 86, 89, and 83. And 82 minus 85 gives me an absolute value of 3. 86 minus 85 gives me an absolute value of 1. 89 minus 85 gives me an absolute value of 4. And then 83 minus 85 gives me an absolute value of 2. When I add all those together and divide by 4, I get a MAD of 2.5. So her difference in her scores is about 2.5 points. And then Jamal is 80, 99, 73, and 88. And then I'm going to go ahead and subtract the mean from each piece of data. And I get a difference of 5, 14, 12, and 3, and then when I find the average of those differences, I get a MAD of 8.5. So what we're seeing is that Lee is the least consistent student. Even though they all have the same average of 85, she is the least consistent. So her scores range, they vary about 11.5 points above and below her average of 85. Then we've got Bessie, who she is very consistent. She only goes above and below her average of 85 by about 2.5 points. And then Jamal's right in between them. So the most consistent student is Bessie. The least consistent student is Lee. And then Jamal kind of falls right in the middle. So which student using the data above is the best academic student? Why? And use data to support your answer. Some people might say Lee because her scores increased and kept getting better and better and better. Some people, you might say that Bessie was the better student because her MAD, her mean absolute deviation, was a lot closer, so therefore she was a more consistent student. And then I'm not sure if anybody's going to say Jamal just because he was kind of in the middle of everything. So you make your decision on what you think, who you think is the better student. All right, now we're going to go on the inside. And I did make one mistake. There's 9 pieces of data here, and I only made 8 boxes. So you will have to add another box to this to fit in the to make sure the data all fits. So find the mean absolute deviation for each set of data of the pulse rates for basketball players after a game. So we have 80, 82, 82, 88, 90, 94, and 102, 104, 106. So we're just going to write these data in there, the data points in there. So 80, 82, 82, 88, 90, 94, 102, 104, and 106. Let's go ahead and find the mean of those numbers, which is 92. So I added them together and divided by 9. And then now we're going to find the difference of the data minus the mean. So 80 minus 92 gives me a difference of 12. And then 82 minus 92 gives me a negative 10, but the absolute value would be 10. And then 82 minus 92 gives me absolute value difference of 10. And then 88 minus 92 gives me a difference of 4. And then 90 minus 92 gives me a difference of 2. And then 94 minus 92 gives me a difference of 2. And then 102 minus 92, a difference of 10. And then 104 minus 92 gives me a difference of 12. And then 106 minus 92 gives me a difference of 14. Then I'm going to add all these numbers up. So 12 plus 10 plus 10 plus 4, 2, 2, 10, 12, and 14. Add all of those together and then divide by 9. And then you should get a mean absolute deviation of about 8.4 so for their pulse rate. So their average is about 92, and it roughly goes about 8 above and 8 below 92. All right, next we have Jason and Jill, and these are 2 students in Mr. White's math class. On last 5 quizzes, Jason scored 80, 90, 95, 85, and 70. Jill scored 70, 75, 90, 100, 95. Find the mean and the mean absolute deviation of each student. So with Jason, we're going to add all those together. Actually, I don't even need to write his name. I can just add these and put it right here. So Jason is 80 plus 90, 80 plus 90 plus 95 plus 85 plus 70 divided by 5. So his mean was an 84. And then Jill was 70 plus 75 plus 90 plus 100 plus 95. And then divide by 5. Oops. Divide by 5. And so her average was an 86. And then their mean absolute deviation, well, for Jason, the difference of 80 and 84, so I can write this right here. So 80 minus 84 is a difference of 4. And then 90 minus 84 is a difference of 6. And then 95 minus 84 is a difference of 11. Then 85 minus 84 is a difference of 1. And then 70 and 84 is a difference of 14. So this is for Jason. And then if I add all those together and then divide by how many there are, so 4 plus 6 plus 11 plus 1 plus 14, and then divide that by 5, I get roughly about 7.2 points above and below his average. And then if I do Jill, I have Jill's average is 86, so I'm going to subtract 86 from 70, and I get a difference of 16. and then I get a difference of 11, and then a difference of 4, and a difference of 14, and then a difference of 9. So 16 plus 11 plus 4 plus 14 plus 9. And then divide that by 5. So she had a bigger MAD. So he was more consistent. Jason was more consistent to his average of 84. And Jill was a little less consistent to her average of 86. All right. So using your answers for number 2, answer the following questions. Which student had the better average? Well, Jill had the better average. Which student was more consistent? Jason was more consistent. How do we know? Well, Jill's mean was higher. And then Jason's MAD was lower. If Mr. White was to choose a student to be on the math team, who should he choose and why? Well, if I was going to put someone on a math team, I'd probably choose the more consistent person because I know that they're going to give me what I need. So I would actually choose Jason because he's more consistent. Okay. All right, and then what I would like for you to do is I want you to go ahead and answer numbers 6 and 7. So you're going to be comparing the Smith family and the Jones family, and we want to compare their MAD and then their range, and then which family has the greatest difference in ages. And then you're also going to do number 7. So Sherry has an after-school job at Papa John's, and we want to be able to compare her median and then find her mean absolute deviation. And then you've got some more practice over here, 1 through 8. So go ahead and complete those. There's really no comparison. You're just kind of practicing over and over again how to find your MAD. So if you have any questions, comments, or concerns, please write them at the bottom of the video or ask tomorrow in class. I hope you guys have a great afternoon.